Good afternoon, everyone, and thank you for joining us today. My name is Joelle Guinette, and I'm the Territory Sales Manager at SOLIDWORKS for Eastern Canada. Welcome to the presentation. Today's topic is SOLIDWORKS MBD, and with me is Michel Cloutier, who's the Territory Technical Manager, who will be showing you how the tool works and the advantages of this tool. But before we get going in that, I just want to start with a little bit of information regarding SOLIDWORKS. You know what we offer in terms of the 3D solution, I'm sure, but we've been working really hard for the last number of years to bring you other solutions to complement this and to help companies really improve their design process so that you can either do things in parallel or you can do things quicker. All of this helping you save time, helping you save money, helping you make better decisions and come out with a better product at the end. So for example, we have communication products that help you save time, do things in parallel as you can start documentation with the project. You can do drawings or images for this documentation from your 3D models, not having to wait for products to be available to take pictures. We help you make better design decisions along the way, make sure you're going in the right direction. This would be with products such as simulation, so that you have an idea if you're going the right way or the wrong way, and help make you the right decisions as you go. And as you're doing all this, we want to keep you organized. So we want to help you keep everything in one place. We want to help you find things a whole lot quicker, make sure you don't lose data, make sure you don't overwrite data by accident, and all of this is done with data management. And then we help you integrate with your other design teams or other processes within your company with products such as electrical and as PCB that we've introduced recently, and try and bring everything together from beginning to end in one design environment as best as we can. So in doing all of this, we came out with a product called SOLIDWORKS MBD. The reason for this is the following. There was a research that was done a few years ago by the U.S. Secretary of Defense, so military in the U.S. predominantly, and they came out with the following staggering statistics in their design process, that a third of the engineering dollars that they were spending was going towards creating 2D drawings. And that, okay, maybe we need to do these, but at the end of the day, 60% of these didn't even match with the 3D models that existed. So there's obviously a concern that came out of this study that we're spending time, we're spending money, and that at the end of the day we may not be building the right products because things don't match anymore. So that was a great concern, and out of this came out what's called MBD, so Model-Based Definition, which is a very powerful tool. It has a simple process or a simple idea to it, but the result at the end of the day is very powerful. So here's an example of what struck me for MBD. This is just to give you a little taste of the power that's behind it. This is an example of a part that you see in the top left corner that's documented in 2D drawings. Here's what it looks like. And lo and behold, if you were to do this in MBD, here's what it would look like on the right. So as you see, it's much easier to read. It's a cleaner image, it's cleaner information, just easier to find your way around, and you're going to see how we get to do this. You're going to see what the advantages are of this and the time savings that this could bring to your company, and keeping everything in sync. So hopefully this gives you a little taste of what we're going to show, and I'm going to hand it off to Michel Cloutier, who's been with SOLIDWORKS for over 10 years now. Every year he gets to work with these tools, gets to master as many of them as he can in our portfolio, and obviously learn all the wonderful new things that we add to these products year on year, and he's going to take you through MBD, and hopefully you'll see some value for your company. Over to you.
Awesome. Well, thank you, Joelle, and welcome everyone. So I'm going to be showing you a little bit of MBD. Before I start, I just want to point out that if you do have questions, there is a little question section in the GoToWebinar interface. So please type it in, as every one of you are muted right now, and I'll try to answer them as much as I can after the session, depending on the number. If I cannot answer all of them. I'll answer them offline via email. But let's get back to the topic of SOLIDWORKS MBD. So a lot of people often question me and ask me, what is model-based definition? Well, first of all, MBD, the acronym, stands for model-based definition. So the question is, okay, so what is it really, MBD? So let's say I want to make this part. Most of you, if you want to manufacture this part, will start with launching SOLIDWORKS and actually doing a 3D model of the part. But that's not enough. Just sending a 3D model for manufacturing isn't enough. You need to convey the information about how to manufacture this part. You need to convey information such as dimensions, tolerance, geometric dimensioning and tolerancing, surface finish, whatever it is. You need to document this a little bit better for manufacturing. And in doing so, most people today, what they do is that they create, based on the 3D model, they create another file, the drawing, and they put all of that information on the drawing. As you can see here in a quick example, dimensions, diameters, bolt circles, hole patterns, the like. The idea really behind model-based definition is rather than having two files to maintain, two files to update, two files to deal with, is why not host all of the manufacturing information directly on the 3D model, since that's where everyone starts with a 3D model. And in that process, all the dimensions, notes, and whatever, they all became known as product manufacturing information, PMI for short. So really, the idea of model-based definition is quite simple. Rather than doing a drawing, have everything you would typically put on a drawing, have that hosted by the 3D model directly. And that's what we're going to take a look at today, looking at SOLIDWORKS MBD. That was a simple example, but I'm sure you can relate to something much more complex. It's harder to understand. Some drawings are really difficult to understand. They lead to, misinterpretation and things like that. So that's really what we want to avoid. And the model-based definition itself is part of a growing process. It's like a journey that more and more companies are going to. It started 20-odd, 30-odd years ago with with 2D drawings. Well, maybe much even earlier than that, where everything would just be a 2D drawing. Most of the companies, most of our customers today are model-centric, meaning they create a 3D model, but they still do a 2D drawing, and that's the 2D drawing that's going to manufacturing. The 3D model kind of stays at engineering. And that's going into a shift where more information is now kept on the 3D model. We're moving toward what we call a model-based definition environment, where the model holds most of the information, and that's what gets sent to manufacturing. You might create drawings, but that would not be the norm. That's where people are going. And at the end of the day, the long-term vision is to have everything based around the model. Think of simulation, think of manufacturing, think of inspection, think of everything you want. Everything would be based off of a 3D model, not necessarily off of a 2D drawing. But let's get to the topic of today, which is SOLIDWORKS MBD, and let's see what we're going to do. So the example I'm going to use today is from one of our customers, and what they do is that they do underwater high-end camera for Hollywood studios. And when you start digging into the components, you realize there's a lot of complex, very small, I was going to say high definition, but high precision parts inside this assembly. And we're going to use that model to work the process of doing a model-based design, model-based definition, rather than doing a 2D drawing. So what I'm going to show today are three things. First, how to add and organize the PMI. Remember, PMI is for product manufacturing information. We're going to talk also about configurations, because a powerful tool inside of SOLIDWORKS is the ability to create configurations. How do we deal with that in that environment? And next would be how to share the model-based definition data outside of SOLIDWORKS, because everything we do is inside of SOLIDWORKS, but you have to share that outside of it. And we're going to talk about that. So first things first, we're going to start by opening the part you've seen on the screen, and we're going to work our way into creating and adding the product manufacturing information using tools such as DIM Expert built inside of SOLIDWORKS Standard. So let's go ahead and do that. So for the time being, I'm just simply going to turn off my webcam so we can really focus on what's on the screen. Going to SOLIDWORKS, here's my quick assembly. I'm going to simply open up this part and start adding some information. Now, typically the first things or something you find on pretty much every drawing are just general notes. And very easily, I can simply apply different types of notes right inside of my SOLIDWORKS environment right here. Let's just reposition those notes, zoom back in, and this is just text file, regular text file, very similar to what you would find in a drawing. You can even tie this to custom properties such as material. So now that the material is tied to the custom property, the mass is updated automatically, and then we're going to start capturing these 3D views. If you look down the bottom here, that's this bottom tab, we're going to populate this with views just like you would populate a drawing with views. So we've got our general notes already, but we need to add some dimensional information. So using DIM Expert, I'm simply going to say to start defining this. Now, the first step is simply to define the datum. So I'm simply going to say this is my primary datum, secondary datum, and if I rotate this slightly, I'm going to define this hole that's actually a continuous feature as my tertiary datum. Now, next thing is I want to define what I'm dimensioning. So rather, I could do all features, but really I want to dimension, let's say, this set of holes and this one right here. And as I do this, I can simply now click OK, and now SOLIDWORKS is adding this PMI information, my general tolerancing information is shown here. Now on the left here, you can see all the manufacturing feature, but ideally I want to see the annotation. So here I can see my different datums, the different dimensions and GD and T I'm adding, and now I want to start organizing this a little bit better. So if I orient from the front view, this is my front orientation. So now I can create snapshots. I can start capturing these views just like you would in a sheet of paper, except I'm simply capturing 3D views. So very quickly, I've got the front view defined already. So let's move to the top view where I want to capture a bit more information. So here's one of the holes, or actually the set of holes. You'll actually notice that it actually captured the pattern, so it understood even by selecting one phase that this was actually a pattern of the same, and added the GD and T information. But now I want to also add the positional, and for that I need the basic dimension of this feature. By right-clicking on it, I can access the basic dimension. And sometimes you'll see that some of those dimensions might actually get oriented in another orientation, but it's very easy to reposition them. I could simply control select the dimensions here, and I could then reposition to the top. So now if I reorient to the top view, all of my dimensional information is in this orientation. So now it's just a matter of organizing the data so it's easily readable. And just like that, I've captured my top view. So like you would in a drawing, I captured a front view and I captured a top view. Now going back to the front view, I need to add some more information over here. I want to define the whole pattern. So going back to the auto-dimensioning scheme or auto-dimensioning tool inside of DimExpert, I could say, for example, this is my primary datum just for the whole pattern. And by zooming over here, I'm going to select one of the holes, and notice that SOLIDWORKS actually understood that this is a pattern of the same feature, so that's why it grabbed the whole pattern. And by doing this, I'm adding all the dimensional information for the whole pattern as well. But now it's starting to get a little cloudy. You know, there's starting to be a lot of information, so I might want to actually separate the whole pattern information from the rest of the model. So very easily, I'm going to say that I want to insert a new annotation view based off of the front view, and I want to move these 3 dimensions to my newly created annotation view. And now I could simply recapture this and call it bolt pattern, just like so. So very quickly, I've got my view here, that's my bolt pattern, and I've got the front view, that's the other features that were showing a little bit earlier. So very quickly now, I'm able to separate this information so that it's very easy to understand. Now really what I've done is that I was able to quickly annotate using DimExpert, but also organize that PMI information using SOLIDWORKS MBD, capturing my views down the bottom, just like you would in a drawing. Now let's go ahead and continue with the work. I still need to add some PMI information. I'll do some more, but manually this time, rather than using the auto-dimensioning scheme tool. But we're also going to talk about configuration. So going back to SOLIDWORKS, as I was saying, I want to add a bit more information. So I'll go to the right view this time around, and I want to add some annotation over here. So let's just hide this for the moment. And manually, if you want to add dimension information manually, it's very easy to do as well. In this case, I want to grab all of these faces as being a single manufacturing feature. And as I do this, I'm now able to simply put in some dimensioning. I could also dimension using single edge selection, just like this. Let's add a couple more just to finish the model. So I'll say, here's my height information and maybe the thickness of that base plate right over here. And as I'm doing this, you can first of all see the dimensional information that when I select, it actually highlights on the screen what's being dimensioned. So that's a really nice feedback. But talking about feedback, I can also color code my model, and that shows me what has been dimensioned, what has been tolerance, and what has not. So here you can see that the green faces are actually being fully dimensioned or tolerance for manufacturing, but I need some more information. So for example, I might want to dimension this fillet here. Notice that if I select this, it will also understand automatically this is a chamfer. And by doing that, now you see some more coloring happening on my model, meaning I've got more information ready for manufacturing. Sometimes too, it can be quite difficult to dimension things like, you know, dimensioning to a projected edge like you would find normally before the rounds on this part. So if you want to do that, it's fairly simple as well. You can simply use a projection of these two faces and then dimension to that projected axis, if you'd like. Or you could do the same thing, but for the top one over here. Now, as I'm doing this, it's projecting a normal dimension, but very, very easily you can switch that to the XYZ orientation and really have it fit your need for that. So just by reorienting now and now capturing this view, I'm adding a bit more information to this. Now let's move to the left side and let's detail this whole pattern that you actually partially see detailed already. Now, I know that when I've modeled this, I use some sketch or feature dimension I'd like to reuse rather than doing it all over again. And that's easily doable as well. So you could, for example, activate all my, whoops, let's go back to the left view. I just wanted to show this. And you can show all the feature and sketch information. So you could, for example, grab all dimensions from this over here and assign it to my left view. So now, with a mix of dim expert annotation and feature or sketch dimension, I can start capturing this information into a view as well. Now, going forward, I also want to detail part of this design, but that's on this face that's being highlighted. Now, the problem is, there's something in the way. The front plate here is kind of in the way, so ideally I'd like to use a section view to do that. So let's go ahead and create a new annotation view based on the left orientation and use a section view to cut through the model. So now, very quickly, I've created a section view, and I'm going to call it as such, section view. And I'm going to detail more on this section view. What I want to detail is actually the whole pattern of this feature here. So I could simply grab or add the dimensional information for this whole, but I need to add some GD&T, some geometric tolerance to it. Now, before I go forward, a couple options. A lot of people often ask me, how do you treat, how's the default being handled? And that's all being handled through the document properties, where you can see here, how it reacts when you decide to dimension different dimensions, what's the default and everything else. And here I'm going to turn on the create basic dimensions automatically. So as I'm doing this, if I add a GD&T symbol to this, and we're going to say not perpendicular, but actually positional, diameter, maximum material condition, we're going to dial this down to 0.2, and then I'm going to set my primary datums as A, B, and C. Now, I'm going to actually, on purpose, make a typo just to highlight something that's really interesting. The fact that there's actually some GD&T checks happening inside of this user interface. So dim expert is actually smart enough to understand true GD&T, and it will warn you of errors like this. So for example, I don't have a tertiary data named D, so I'll simply use C, and that arranges everything. And as I do this, you see I've added my GD&T information, but also the basic dimensions were also set as well. So now if I reorient very clearly, we can see the section view right here that's dimensioned differently than the front plate. So that's the whole idea of creating a section view right over here. Now, the last thing I wanted to show here in this little bit is how to talk about how to deal with configurations. Typically, if you had a part with multiple configurations, you would create multiple drawings. So you would actually end up with maybe 2 or 3 drawings. But here in SOLIDWORKS MBD, you can also capture all of this within the same model. So going back to SOLIDWORKS, just to show you real quick, actually let's start from the right view. Just to show you real quick, if I go to my version 2, you see here this part is quite different from the first one. Okay, it's not the same color, but even the shape is much different than the first one. But I need to convey the information. I need to put the PMI information on this model as well. So what I could do is I could simply, rather than doing everything all over again, simply copy what I've done from one configuration to the next configuration. You'll see some information dangling here simply because the part cannot hold that information anymore because it's a different shape. But very quickly, I'm able to add this information to my new version, and we're simply going to call it version 2. So very quickly, I've got my version 1 here with the GD&T, the dimensioning and tolerance for this version, and then I've got my second config with the GD&T for that one. Now, if we recap a little bit and we go back to the full model with all the GD&T information, you can see that I've started and adding all of this dimensional information. And sometimes you just want to query the model a little bit. So a nice little tool here is the dynamic annotation view, where actually it kind of filters out what's not in view. So only what's, kind of normal to the screen is shown when I rotate the model around. So it just makes it really easy to understand when I'm simply navigating on the model rather than seeing everything on the screen. So this is, what I've shown you really is how to save a lot of time. Again, I haven't done a drawing yet. I don't need to. I can just have all this information hosted on the 3D model. And that, in turn is just a time saver. You just save the time of going through that process. But when I say that, people tell me, all right, so great, you've got all of this on the 3D model, but how do you share that? Not everyone is using SOLIDWORks because, yes, everything is on a SOLIDWORks model now. And even if people would be using SOLIDWORks, people don't like to share the native SOLIDWORks file. So there's actually the solution to that is actually twofold. We could use eDrawings, but another solution is also to use PDF because everyone knows of PDF. So let's see how we could share this information from SOLIDWORks MBD to someone outside the company that might not even have SOLIDWORks at all. So from SOLIDWORks, and actually from SOLIDWORks MBD, I've got two options. First of all, you see one here, publish an eDrawing file. So that's by now you should be aware of what eDrawing is, so you can share that very easily. But I think most customers will appreciate the fact that we can also publish this to a 3D PDF. And by doing so, you get access to many types of templates. What's kind of neat with SOLIDWORks MBD is that also with SOLIDWORks MBD, we give you a template editor. What that means is that you can create your own type of PDF template where you're going to publish your design. You see here's a couple different samples that are installed with SOLIDWORks. I actually have a few sets of different samples. So basically you organize your PDF template very similar to how you would a drawing. And when you're ready to go, let's just close this. You're going to select the template right over here. You're going to select the different views you want to publish. One of the neat features as well is that with that, you can also send or capture information from the 3D model, from your SOLIDWORks model. So for example, you could capture part number and description and have that populated already in the PDF template. And when you're ready to go, you just click OK, and it actually creates the 3D PDF. Now, what does the 3D PDF look like? So let's take a look at one that's already completed. It takes a couple of seconds, so I'm going to save you that. And here's the example of this file I've created. I've published a 3D PDF a bit earlier. And you can see that on top it actually captured some of the information like material and things like that. But what's important though is that this is a PDF, but it's a 3D PDF. I can navigate through that part as a 3D model. And down the bottom you'll see my views. Remember the views I've captured today? So here's the front view, here's the flange holes, here's the right view. And as I'm doing this, it also becomes very easy to understand because if I select a dimension on the 3D PDF, it actually highlights on the screen. So it's very, very easy to understand which is, what this dimension is and what it relates to. I can also have, here's one with my section view. Remember when I created that section view Well, here it is with the dimensional information for the hole. Just by selecting the dimension, I can see that this applies for these two holes. And I also have information about my version 2 file. So within the same PDF, and this is a free Adobe Reader, everyone can really navigate this and understand this very easily. Moreover, if there's any dimensional information missing, Adobe Reader actually has the ability to measure this right over here. So very quickly, I could dimension this right from my 3D PDF. So if there's any dimensional information missing, very easily I can do that. Here's another example, this time for an assembly, because yes, SOLIDWORKS MBD works also in assemblies. You can also create section views, add some dimensional information to the model inside of this assembly. What's kind of neat though with assemblies as well is that you can also embed a bill of material inside your 3D PDF. And that bill of material is actually interactive. As I select an item in the bill of material table, it highlights on the screen. The opposite is also true. If I select a part on the screen, it will actually scroll to the item in the bill of material. You can see here that shaft is actually item 12. If I select from the bill of material, both of these two shafts, quantity of 2, actually highlight over here. So sharing, MBD information is really easy. Again, there's two options. You could use e-drawings, but if there's one standard in the digital age, it's probably a PDF file. And this is a Adobe PDF file that you can read with free Adobe Reader. So it really allows you to communicate the design with anyone. Pretty much everyone now has an Adobe Reader installed on their computer. So quickly, what we talked about today. So I kind of went through fairly quickly, but briefly, and hopefully you get the big idea of what SOLIDWORKS MBD. We quickly annotated the 3D model and organized that PMI information into views, very similar to a drawing. The difference is that the views are hosted on the 3D model. Well, I saved a ton of time not by having to do drawings. And remember my two configurations. Typically, that would have required me 2 different drawings. Granted, I didn't dimension everything, but I was in a good shape there. And really, how we can communicate all that information really with everyone using 3D PDF. 3D PDF just is the norm, right? Everyone knows of 3D PDF. Maybe before I pass it back to Joël to wrap things up, I do have a question. Let me read that real quick. MBD works well with parts. Working with large assemblies, that's a good point. So we are aware of, as you can see, we can work easily with assemblies. Sometimes with large assemblies, one thing that comes up is the scaling of the annotation, and we are actually working on that for the next release. So that's going to be a lot better for that workflow, especially for large assemblies. That's going to be a lot better. So thanks for the question. So Joël, do you want to wrap things up?
I would love to. Thanks, Michel, for all that great information. And we started the presentation by showing you why it came to be with the military in the U.S. Starting this out, but it's gone much further than that. If you take a look at the names that are on this slide, you'll see that there's a lot of companies who have taken a look, obviously trust the information and realize the information themselves, that they're wasting a lot of time creating 2D drawings, that they're wasting a lot of money because they're not in sync with the 3D models, and are putting in place procedures and processes within their company to go towards the MBD model. They invest, you invest, they invest, everyone invests so much time and energy in creating this 3D models, then why not just stay with them, enable more information to be accessible from them, and keep using that instead of going to 2D. And this is where we're going. So this is where these companies have already gone, not necessarily on a full scale to start, but definitely on large initiatives for some of them, putting a percentage on number of designs that are going that way so that they can take advantage of all the benefits of MBD. And here's a quick quote that we have that kind of puts it all back together in what it does. This is obviously from somebody from GE. And it says very simply, with SOLIDWORKS MBD, the 3D model itself holds all the dimensional data necessary to make the part. This means less documentation creation, fewer emails flying around, and fewer files to sustain when the project is complete. So all good things, right? And I'm sure that you've seen through the process, as Michelle has explained it, how that's enabled, how MBD lets you do that. The next step is figuring out how this can work and help your company, your enterprise. And if you have questions or want to have that conversation with us so that we can determine if this is and how this is going to be good for you, then we'd be happy to help. So our coordinates are on the slide here. Please take them down. You also all work with resellers that will either reach out to us if they need additional help or will help you themselves to find out how this could benefit your enterprise. So please don't hesitate to reach out to someone within the organization of SOLIDWORKS or the resellers to get some more details on MBD. You will be receiving a copy of the recording of this presentation, so feel free to pass it along to anyone else within your corporation you feel needs to see this. And we hope that this was of benefit to you. We thank you for spending the part of your afternoon with us, and hopefully we'll see you on some more of our information sessions as the year goes on. Thank you very much, everyone. Have a great afternoon.
Thank you, everyone.